Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we'll be talking about Rutherford scattering experiment, guys. So this will be part of the GCSE in the nuclear physics topic, and make sure you've watched my other videos on that topic before watching this one, otherwise it just won't make sense. And obviously, guys, make sure you hit the like and subscribe button to keep my channel going and keep my content as free as possible, guys. Right, so first of all, make sure that you've watched my other videos on the history of the atom, because today I'm going to explain how did Rutherford come up with this model of the atom. So as you can see here, we've got the Rutherford model of the atom. In the center of the atom, he proposed that there was a nucleus, yes, which was positively charged. So the nucleus that he proposed was going to be positive. And he proposed that there were electrons which are going around it. And there you go, guys, I've drawn the electrons here. But how did he actually get to this actual model? Well, I'm going to explain it right now. He did the following experiment. Right, so he thought it would be cool to actually fire some alpha particles at a thin piece of gold foil. So as you can see on the left hand side, I've got the alpha source, and he fires it at the gold foil. So the alpha source is emitting alpha particles. So I'll draw some of them coming out over here, and they are going to hit the gold foil. That was his experiment. If you have forgotten what an alpha particle is, it consists of 2 protons and 2 neutrons, because it's like a helium nucleus, and therefore it has a charge of +2. I've got another video on that. You can watch that video to understand what an alpha particle is. So he is firing these positively charged particles at the gold foil. And we're going to talk about his observations. Well, he observed that most of them pass straight through. So loads of them. So most pass straight through, guys. Most of them pass straight through. He also observed that some of them were deflected by large angles. So some of them were deflected. Some of those alpha particles were deflected. And he also did the following. He also detected that some of them came back at extreme angles. So some of them actually came back on the same side as the alpha source. So very few, so this is very few compared to the other ones, deflected by extreme angles. So this is what he did, guys. He fired the alpha particles at the gold foil. Most of them passed straight through, some were deflected, and very few were deflected by extreme angles. How was he going to explain his observations? Well, obviously, this is where his model kicks in. And now I'm going to use his model to explain how this all works together. Alright, so the explanation is the following. So here on the left hand side, I've drawn some alpha particles. Yes, that was a symbol for alpha. And we're going to fire them at the gold foil. So instead of the gold foil right now, I've redrawn it as one of the atoms he proposed. Okay? So the alpha particle, this one over here, well look, if we fire it, we will notice that it will simply pass straight through. Yeah? Okay? This one as well, if we were to fire it using this model, it would also pass straight through. Yeah, because there's nothing there. This one, as you can see, it will travel, but oops, it will be deflected. It will face some deflection over here. Think about the reason why it is going to be deflected. This one, as it travels through, whoops, will obviously go all the way back. Will go all the way back again. Think about why do you think this one is going back, this alpha particle? This one going all the way, but then, oh, deflected. Okay. What about this one? This one will go all the way, but pass straight through. And the last one will go all the way through and pass straight through. Right. We are going to now explain why is it that most of them pass straight through using this model? Why is it that some of them were deflected using this model? And why is it that some of them were deflected by extreme angles using this model? Right, so most of them pass straight through. What is the reason why though? Think about his model. What did his model propose? Well, we can clearly see from my diagram the reason why they pass straight through is because most of the atom is made up of empty space. So put that down as most of the atom is made up of empty space. That's the key thing here. Most of the atom is made up of empty space here. Right, next one then. Why is it that these ones were deflected? What could be the only reason why? Well, it's about the actual charge of the alpha particle itself. So previously, at the start, I talked about the charge being +2. it was a positively charged particle. If it's a positively charged particle, the only reason why it would be deflected is because the nucleus must be positive, because it must be deflected. So that's the reason why some of them were deflected. So the next statement, we can now explain the deflection. So some were deflected because there must be a positive nucleus, as the nucleus is positively charged. There we go. So there we go. Put it down now. So some were deflected as the nucleus is positively charged. So now we know that there must be a positive charge inside the atom because it's deflecting the positively charged alpha particles, guys. That is the reason why you know the nucleus is positive. Last of all, from there, it's going to be why is it that some of them are being deflected by extreme angles? So look, this one's extreme. It doesn't even be deflected. It's by a large amount. It is going to be deflected. So it's deflected by an extreme angle. This is going to tell us about the size of the nucleus itself. So look, it tells us that the nucleus is obviously a small, concentrated positive charge because only very few of them hit it head on. That's the reason why very few come back this way. So some are deflected by extreme angles as the nucleus is concentrated in a small volume. Guys. So only very few of them are going to hit it head on. Because the volume is so small, only very few would hit it head on to have these extreme angles. So the nucleus is concentrated in a small volume, therefore very few hit it head on. Therefore, very few alpha particles hit it head on. Hit it head on. Alright, so as you can see, guys, I've used Rutherford's model to help explain the observations from before. We know that when Rutherford fired the alpha particles into the gold foil, most of them pass straight through. The reason why is because most of the atom is empty space. Some of them were deflected. The reason why, so look, some were deflected. The reason why is because, obviously, there must be a positive charge somewhere repelling the alpha particles away. And obviously, alpha is positive. That's why the nucleus is positive, because you want the repulsion. And last of all, only very few are deflected by extreme angles. The reason why is because that mass of the nucleus is in a concentrated unit of volume. So very few hit it head on. And that's it, guys. Okay, so a quick summary, guys. I'm just going to make a table now of observation and the explanation. Here we go. So, observations and explanations. The observation, most of the alpha particles pass straight through. Explanation, most of the atom is made up of empty space. Observation, some of them were deflected. Explanation, there must be a positive charge inside the atom. Last of all, very few were deflected by large angles, extreme angles going all the way back again. The reason why is because the mass of the nucleus is concentrated within a small volume. So the mass of the nucleus is concentrated in a small volume, guys. That's the reason why. So we've got all the observations now being explained over here. And that should make sense because that's how we end up with the model that we started off with, guys. So make sure you understand the experiment, make sure you understand the explanations, and make sure you can summarize it with the observations on one side and the explanations on the right-hand side, guys. Okay, so from here, quick recap right from the top before we get going. So right at the start, today's title is Rutherford's scattering experiment. Scrolling down, I talked about Rutherford's model of the atom and discussed how on earth do we get to this position. So when the nucleus is positive, electrons are orbiting it. Well, we talked about his experiment in which he fired alpha particles at the gold foil. And what he realized was that most of them passed straight through. Some of them were deflected and very few were deflected by extreme angles. Then, scrolling down, we have the explanation. So look, I drew out Rutherford's model and I said that the alpha particles are coming in. What's going on in terms of their movement? We can clearly see that most pass straight through because the atom is made up of empty space. It can be explained that way. Some were deflected. That tells you that the nucleus is positively charged. And very few are deflected by extreme angles. The reason why is because, obviously, that mass of the nucleus is in a concentrated unit of volume, guys. So very few of them hit it head on. And last of all, guys, I made a list of the observations and the explanations one more time for you. And that's it for another session of CeerazzleDazzle Physics. Make sure you like and subscribe to get my channel going. Good luck in your studies. And don't forget that you should never trust atoms. The reason why is because they make up everything. Ciao, ciao, and goodbye.